Section 3.5 talks about overlapping triangles. One of the most difficult things in doing these types of problems is looking at the diagram, deciding how many triangles there are, and if indeed there are overlapping parts to the triangles. If you look at the first diagram, you can see 3 smaller triangles, 2 on each side, and then 1 in the middle. But what might be a little bit harder to see is the 2 bigger triangles within this diagram. There's one here extending to the right, and then another on the left extending, or on the right extending to the left. What you should notice is that both these triangles share a similar side here at the bottom. You can prove those 2 sides congruent using the reflexive property. Take a look at the diagram on the right. Again, you probably noticed the 2 smaller triangles on the bottom. But did you notice the other 2 larger triangles within the figure? There's one here, and there's one here. And hopefully you see it does have an overlapping angle up at the top. Again, you can prove that this angle is congruent in both of the triangles using the reflexive property. This can be a very helpful tool when you're trying to prove that 2 triangles are indeed congruent. Take a look at our example here. We're given line segment NR is congruent to line segment NV. We know that points P and Q are midpoints, and angle R is congruent to angle V. We also are given that line segment PQ is congruent to QR. We are trying to figure out or prove triangle XST to be isosceles. Now, even though we haven't quite gotten to the definition of isosceles, they tell us we can establish it is an isosceles triangle by proving 2 congruent sides. Take a minute, look at your diagram, and write down all the givens and mark it on the right. Now, let's look at the diagram and see what they're actually asking us to prove. They're asking us to prove that in this triangle right here, XST, there are at least 2 congruent sides. And we need to figure out how we can do that. We can maybe take a guess that we're trying to get XS and XT to be congruent. Well, if you look at those 2 sides, you'll see that it's a part of a larger line segment that extends to P and Q. If we continue that, you'll notice that QS and PT are also a part of larger triangles. If we can establish that those triangles are congruent, we can then establish that the corresponding line segments within the triangle are congruent. Therefore, the little piece is congruent to establish the isosceles triangle. But how are we then going to establish those triangles? Well, we do know angle R and angle V are congruent. Well, what else can we say about this triangle? Well, we know P and Q are midpoints, which basically means that these are going to be bisecting segments to the longer segments NR and NV, which will then, using the division property, establish that PR and QS or QV are congruent. So in my proof, I go ahead and I establish my givens. And then using that P and Q are midpoints, I can say that they bisect the line segments based on the definition of a midpoint, that if a point is a midpoint, then it bisects a line. And since we know we have 2 bisecting segments with 1 larger segment, we can then use the division property, like we just mentioned, to establish the smaller segments to be congruent. So then let's look back at the top. To try to get the purple and the green triangles congruent, we know that one of the angles was congruent. We now established that a side is congruent. The next step would be to establish that either another angle would be congruent or another side, to establish ASA or SAS, side angle side or angle side angle. What you need to decide is what you can prove from there. Since we do not have any line segments on the bottom here proving congruency, it will be very hard to prove that RT is congruent to VS. So let's look at the angles RPT and SQX. How can we prove those congruent? Well, we notice that they're a part of a supplementary line. So if we can somehow prove that these angles right here are congruent, we can easily prove that those original angles to be congruent as well. So how do we prove that NPT and NQS are going to be congruent? Well, what we can try to do is establish another triangle or congruent triangles in there. So we'll draw the line NX, and the reason for that is 2 points determine a line. Now, do you see the two new triangles that we have just created? NPX and NQX. We can say NX is congruent to itself based on the reflexive property, and we can also say that NP is congruent to NQ, again based on the division property we established earlier. That creates two congruent triangles based on side, side, side. Since we established the congruent triangles, we now know the corresponding parts of those triangles are congruent. What that means is we now know that this angle right here is now congruent to this angle. We can then say that NPX and XPR are supplementary, as is NQX and VQX. Once we establish that they're supplementary, we can then establish that RPT is congruent to VQS, because if congruent angles are supplementary to congruent angles, then they are themselves congruent. Now that we've established that the two angles are congruent, we can go back to the highlighted triangles. We have an angle proved congruent, we have sides proved congruent, and now we've just established another set of angles being congruent. Therefore, the two triangles are congruent based on angle, side, angle. Now, knowing that those two triangles are congruent, we can say that the corresponding segment crossing into the isosceles triangle are congruent. So PT is congruent to QS based on CPCTC. Now look at the diagram. Both those line segments cross what we're looking for, QXS and XT, which are part of that smaller triangle we're trying to prove to be congruent. We can now say that XS and XT are also going to be congruent based on the subtraction property. Once we know that both of those sides of the triangle are congruent, that establishes that indeed triangle XST is isosceles.